Hi, guys. How are you?
Very good.
Good.
Yeah. Okay, let's keep the conversation going.
So, hi everyone. My name is Ola, and my teammates are Daphne, Eugene, Tyler, and we're the water team. So, next slide. So this year's brief in Spiropolis Studio, we were asked to explore the elementals that make up this earth. Water as an elemental offers a great deal of ways to sustain life and harvest resource, whether from clouds, rain, oceans, seas. Water touches every aspect of our lives. We put water to work in a million different ways for different uses. As Leonardo da Vinci puts it, water is the driving force of all nature. Water enables growth. It is the key to the founding and shaping of life. Throughout history, humans have always settled near water bodies. It enabled the growth of urban cities around the world and water settlements, which have thrived for many centuries. Whether these populations flourished or not depended largely on smart water strategies. Those who harnessed water thrived, and the ones that failed fell. The relationship of the water settlers to their surrounding runs very deep for generations. Not only does water provide them with all the life necessities, but they have become part of their surroundings. The existing water infrastructure around most of the world is based on centralized systems. Water megastructures are the most constructed infrastructure that are invasive, stationary, not adaptive to natural changes, and designed based on the abundance and have a lifespan. Sadly, due to nature, the world is becoming warmer and water is becoming scarcer and demand is continuously growing. Accessibility to water to some have been difficult. In many locations, I'm sorry, we're having a technical issue. Sorry, in many locations around the world, mostly Africa and Asia, the water crisis grew people apart, creating conflict around it. Water has become an important political element as well. Many attempts have been made. On one hand, there have been extreme strategies such as cloud seeding, which increases the chances of precipitation, or strategies such as moving an iceberg. On the other hand, people have used primitive smart strategies like the Waka Tower, which are deemed decentralized systems that addresses the local meteorological conditions, the geomorphological characteristic of the site, and the local culture. This kind of strategy provides sustainable solutions for rural and isolated communities to access to water. Communities should grow within the capacities of their system. This is a need to increase regional adaptability, a call for a decentralized off-grid strategy. What if we can personalize water? What if we can control clouds? What if we can siphon them? Learning from the simple rules that follow the formation of clouds, getting inspiration from the lightness of structure of nature. We aspire a mobile infrastructure on the move. We aim to create a light infrastructure of water that is movable and floating, a shared infrastructure that is not fixed, unlike the existing infrastructure. An infrastructure on the move, a shared infrastructure on the move that is not fixed, and unlike the existing infrastructure, agents that respond collectively, that capture, retain, deliver, release water, and generating a route based on a feedback loop from weather patterns and diversified demand.
Inspired by the cloud intelligence, the phenomenon is based on an intelligent process of phase change from liquid to vapor and back to liquid. The process of this phase change occurs throughout the journey of these fake water vapors within the altitudes. These would finally stick onto the dust and exist in the air. The dust performs as a scaffold for the water droplets to allow condensation. As they stick on the dust, they form a condensation nuclei. Clouds are formed through an accumulation of these nuclei, and as they get heavier, release happens either in the form of water droplets or crystal droplets. We observe different behaviors that emerge based on scale. We analyze the intelligence based on 3 scales. The small is based on the process of the nuclei condensation. The medium is defined through the accumulation of the condensation nuclei, which are influenced by external weather parameters. And release either as snow or as rain is related, which is related also to different types of formation processes that also serves as a recognizing element for each cloud type. The final scale is weather, which is based on the complex system of cloud patterns. Learning from the intelligence of a cloud, we similarly set 3 main resolutions for our water harvesting system. In the small scale, our agent's goal is to capture and retain water. Medium scale is the accumulation of agents, and its main goal is to release water, either in the form of rain or in the form of snow. These 2 different behaviors emerge depending on the environmental conditions. Our level of control is probably in which altitude the water could be released. Our final scale, the main goal is to research for humidity and regulate response according to regulated human demand. We're starting from the small scale, the agent scale. Given the fact that we want water collection typology, we seek for the optimum receiver of water. Harvesting water agents as smart dusts, as we may call them, individually act as capturers, receivers of water in the form of water vapor when humidity is in abundance at a location. The initial state of the smart dust is at rest up until the humidity actuates the smart dust to capture it and starts floating. There are 2 main goals in this state: capture and retain humidity. The aim is not only to retain, but also we should highlight that the typology has to be light and transformable, which allows agents to float and exhibits hydrophilic properties. We are seeking possible typologies for moisture capturers and rain capturers. Our agents should be light, and that's why we explore the different properties of elasticity, stiffness qualities, different densities, lightness, porosity, that would offer us an optimized moisture capturing. Our agents should respond to moisture changes. As soon as it captures the moisture, agents should exhibit qualities of retaining this moisture. Our studies were focused on finding a balance between lightness and rigidity that allows both floating and retaining water droplets. We have concluding, we have to be able to adapt into different behaviors. As we said, by varying our material properties, some parts would work as retainers and other parts would allow the floating to happen. Following this observation, we tested our agents in wind tunnels to study their floating behavior. We noticed that the vortex that is created on the top of this allows floating, and at the same time, the water droplets are being protected. This could be a potential agent for now that offers the basic goals for capturing, retaining, and floating. Of course, we could be looking at a diversification of agents through the diversification of density and porosity, which means different absorption rate. The agent can sense humidity and reacts to that by forming a protection layer. So at this slide here, we can see that how a water sensor, how an agent can sense humidity and react to that. Where our goal is, after capturing, to direct water droplets towards the center where retention happens. Our research journey started off with material that could possess the lightness of the dust and would reinforce stickiness behavior of water. We have experimented physically and digitally the different properties of water that would allow us to understand more the behavior of water in real life. We experimented the retention property of hydrogel as a potential retain strategy. Other experiments were on the different viscosity of fluids to open up possibilities of better retention through interaction of fluids. Some of our previous studies were more focused on directing water flow through a strategy of layering different materials with different performance. We explored 3-layered materials which aim to direct, filtrate, and store, followed by a series of mesh studies to dynamically direct water into specific nodes and understanding water as load. However, we focus more at this point of the research on the narration of autonomous agents that can sense humidity, capture, retain, and finally deliver and release water.
Okay. In the medium scale accumulation of agents, we are trying to think about the application of agent-based aggregation can move towards the places with low water humidity level to stimulate the agents in a controlled way to release water with needs, which aim to control the process from liquid droplets either to liquid rain or crystal. In this way, this becomes our medium-scale phenomenon of release. And in this slide, the volume-based agent simulation, the aggregation begins to form the cloud and behave with different pattern value. In this case, the releasing process and external force will affect together to the agent cloud to perform differently. And in a more conceived base, agent-based cloud could start to generate sequence as the reflection to the wind and capture moisture in a more efficient way by providing volume and tunnels, such as this. Next page, please. With releasing of water and temperature change, the tunnel could integrate with the mesh network to begin the absorb process with moisture. Okay, next page, please. Then we are exploring the control of the fluid agents through the nodes. The nodes in this case represents the local humidity level data. Then agents could find the path based on the data distribution with the low humidity locations. Next, please. Next, please. By adding control points, we can direct the amount of agent flow that allows us to achieve a certain level of distribution systems. Next, please. Within a more complex environment, multiple emitter represents multiple high humidity location which agents have the ability to absorb moisture and air. Then with the control radius, agent will create their path according to the humidity level. Okay, next please.
Thank you.
Thanks, guys. I mean, maybe I'll start and then the guys can join in. I mean, I think that there's been good progress from obviously where we've been, and I think some aspects of what you're doing need to be kind of articulated a bit further in terms of really speaking to the fact that, you know, thinking about, let's say, water management system and thinking about the idea of harvesting water and so forth and utilizing elemental aspects like cloud as a kind of strategy to think about these kind of constructed atmospheres, I think is very important. You've kind of created this sort of triptych of scales, but I think it's really like a triptych of relations, meaning that the different scales of relation are very contingent to the environment and they behave with different kinds of ordering strategies, right? In terms of what we're talking about in terms of the agent on the individual level is the kind of trigger source for the capturing strategy. But that has certain limits on an individual, and it has certain kind of elements, limitations within the collective. So the idea that the collective is not an aggregate, but the collective is a formational strategy, I think speaks to a lot of the kind of time-based aspects of what it is. So I think that that's kind of important in terms of also speaking towards like different ideas of control and different ways of situating really a volumetric kind of understanding of mapping versus, let's say, a 2D description of mapping, because the ability of these things to move water in almost like a kind of effortless way, at least at this stage, needs to be kind of harnessed and deployed. So when I look at the particle simulations, for example, the idea of the particle as an agent that has certain capacity to release, as we've talked about it before, needs to be kind of quantified. And that cycle of activity needs to be diagrammed, because this is part of the kind of perpetual cycle of extraction, harvesting, and calculated kind of deposition or deployment of that. And I think that in a very literal sense, like the last slide that you showed, it starts to become something that's a little bit of a caricature, because in one sense it looks like the rain room with somebody dancing around like we're doing a rain dance to get the water. But realistically, it is like repurposing the concept of, let's say, something like a sprinkler system to something that is a mobile kind of concept of smart dust, right? So I like this conceptualization of cloud intelligence, but I would kill that last slide, because in some sense that brings it into, I know, a kind of playful way of thinking about it, but I think there is something much more at hand in what you're talking about. I also think, like, for example, the first series of slides from slide 11, where you introduce the hair, I think the concept of the hair has to be like the most minute way of generating extraction that is kind of pooled into a form of surface tensioning, right? As these beads are happening on the hair, the surface tension and the hair as a kind of sticky value can concentrate that. And then the question is, if it's being extracted, where is it retained? And how does that actually influence its behavior in terms of speed, in terms of collective organizations? There are different attributes to that. So when you talk about your material experiments, viscosity, for me, at least at this stage, is less meaningful right now, at this moment, because, for example, hydrogel is very clear as that's potentially a water retention strategy. Surface tension, I think, is a way of thinking about one form of kind of choreographed deposition of where the water is going to. And I think the textile strategies is pretty clear as another form of extraction at a different scale. So I think those frame, I think, particular ways of thinking about the digital material. And some of that can be tested with principles materially, but some of it, I think, can definitely be showcased, I think, much more explicitly in terms of some of the kinds of digital experimentation and simulation that you're working on. So I think that there's been good progress in terms of kind of outlining where the project is going. But I think we need to clarify a little bit scenarios, so it's not like, for example, the agents in the humidity scenario, where agents run to humidity, I think is not necessarily the only scenario, but it's posed as one of the primary examples, which in some sense, airflow already has different degrees of moisture content in it. And so, for example, we don't always need to have a water humid scenario to be able to deal with this. You know, the extractive elements of looking at atmosphere at different levels have different degrees of water moisture in the air. And I think that that's an important thing to also qualify what possible scenarios or how the system would be distributed in different places. I mean, Patrick made the point about the desert and radical temperature changes. I mean, in this case, temperature is very much a big part of the way that phase change operates. And in your case, I think is really primary to be able to see the possibilities. So right now it's focusing primarily on moving of water and extracting, harvesting of water. And I think there is also another part of the project that is yet to come, which is basically what do you do with that now when you control the cloud? So we're focusing on the first part of the conversation. The second part of the conversation is, okay, now you've managed a different form of irrigation or a different form of control and movement of water infrastructure that's not plumbing. Now, how do you utilize that, capture it, and create kind of sustainable, let's call it architectural strategies for living with it? So I mentioned that because I think it's important that this is part of the bigger motivation. I thought the film in the beginning was quite clear and I think helpful to kind of speak a bit to, let's say, your conceptualization of the elemental aspect. But the idea of organization now is going to have to be radically considered in terms of the magnitude of how these systems work. The kind of flying elements right now look too much like mechanical systems that are going to be capturing it rather than, let's call it, smart dust. But I know that's the first sketch of this, and there's going to be many more to come. But I think it's useful to visualize so we get to see things in scale and try to understand actually what's visible and what's invisible and how we're sort of manifesting that some way through principled behavior. So I think it's for me, it was a good presentation and pretty clear. But yeah, I think now is the time where you have to really start to push these simulations to hybridize some of that stuff. Sorry, Patrick, you're muted.
Oh, yeah. So it's a beautiful project, so congratulations. It's quite poetic and imaginary, but also has a lot of science to it. And I do find this cloud formations and the individual units in this case quite meaningful and well designed and purposeful. So I just wondered, I mean, so I think there need to be more of them. So the last rendering, and I don't think they make movements like a mosquito. They're slower. And they're changing altitude, you know. It's fascinating. So I really like them, and I was thinking about a scenario for that. I'm not sure you're familiar with these. I mean, rather than sustaining life of, I don't know what you're thinking about. Rather than looking at some kind of the last remnants of a nomadic population who is in a semi-desert. maybe it could be one scenario somewhere at the Sahara or Sahel zone and so on. You find villages and to upgrade and so on. But another scenario for me could be Neom in Saudi Arabia. There's a new city, new resort. They're trying to, to generate an oasis, like bring vegetation. If you're close to the water, then continuously, you have this kind of water, salt water evaporating, which could be captured. This doesn't rain off there; it rains off somewhere else. But if you can capture with these clouds beautifully, you can create, a sustainable, rather than kind of pouring precious water into these gardens, and that could be a way to maintain a certain. And we also be careful what kind of vegetation you maintain and what kind of utilizations you might have. And I can imagine to be in some kind of place like this, a beautiful garden resort, and then you have these clouds, and they're of course they're sort of self-actuating. So I wonder also in terms of, are these little drones, mini drones, where they actually have an active movement capacity as well, and then there would be a kind of ground landscape. And you said there is water demands for various plantations, decorative, or also is food supplies, or maybe that's too corny, but taking a shower or walking in the rain in that desert scape might also be of interest. So yeah, I think it's beautiful, and I can see that there's a credibility. I like the capture, and then yes, the retention, and then the release. It's quite beautiful. They're probably larger populations, and also the individual scale of them. I don't know what it could be. Probably it looks right, but I really like some of the animations and the overall sense of that kind of integration of a technical device and these natural processes. So I really like that.
Yeah, no, I think like the computational aspects are also quite interesting and kind of appropriate, I guess, like that. Combining this physical simulation with some kind of use scenario, right? That right now you have these potentials, right? Like there, whatever are the attractors and so on, like, and how you can deploy it or coordinate it and choreograph it in relation to larger communities of human actors, right? Or yeah, collect. I think that's
the ground obviously isn't just a flat, so there will be either plantations, or you talked about the demand, or basins for if you rain into the kind of flat field, it just sinks off and is wasted. But if it rains into channels or reservoir pools and basins, so that will also be there. There's a correlation between the cloud formation and where the rest sinks and releases or splits up for many smaller, let's say, deliveries, or one larger raining off. I think the whole delivery thing is actually, that's the end user. That's the where you could imagine a kind of different types of rain, distributed, very fine, dusting off, or all kind of nearly like kind of where you would have some kind of re-release partially into the atmosphere, or you have a kind of raining down nearly like a kind of water jet. So I think that landscape between the ground surface and the cloud, and then the rain as a medium, space filling and dynamic medium, could also be part of that. Of that world. So So I wouldn't be adverse for that to be, 21st century, a super sustainable resort experience in something like Neom, whatever, or it is more something which is in some kind of tribal condition in Sahara. I don't know what it is, where it is, but I wouldn't shy away from something which is also more of an experiential rather than an existential condition. Because there's a tension. Because if you're going into the existential, it's a little bit so suspect to have to seek for the experiential as well.
I think that tension is important, Patrick, and I don't think it's fully declared on our side yet until we actually get to understand it better. I think the important part of the things is to think about that the plausibility of actually harnessing some of the phenomenon, I think, is very important. So, for example, like desalination or other kinds of aspects, it's like really kind of shifting the attention of the heavy engineering and, plumbing riser diagram kind of world of thinking about control systems and management, and are trying to bring the experiential as also being something profoundly harnessing that kind of energy in some way. So I think the scenarios that you're talking about are open. I mean, I'm not for necessarily it being in the desert, and I'm not necessarily thinking of it as an urban oasis. I think of it, if the projects are primarily being focused on prototyping and trying to be able to calibrate certain aspects of the atmosphere that, just based on that kind of gradated field, potentially would mean different ways of thinking about how that would be dissipated or how that would be deployed. So I think the comments are quite good, and it's important to have as many real world scenarios as possible, just to consider opportunities, even if they are thought experiments, to see how they're looking at the things at the same time. But I do agree that it has to be much higher population. And I think that they should be thought about as, almost like lighter than air strategies that through harnessing, they start to really ground themselves. So even the condition about what the ground is relative to the atmosphere can be part of that cycle of delivery, and part of that kind of idea that is also part of the architectural implication. I don't think that they have to be completely discretized systems or strategies. So I think that there's a lot to do. But anyway, I think it's important to somehow also speak to the capturing of the beauty and the fact that these things become much more elemental, and what opportunities are afforded by thinking about things this way instead of brute force engineering. So I think those aspects, are very meaningful to do, and to keep quite sensitive in terms of how you work on it. I don't know if there's any last comments, otherwise I think we can move on. Okay, guys, thanks for that.
Thank you very much.
Keep pushing.
Right.
Keep pushing. It's just starting to come into focus, so use that energy to keep kind of pushing towards phase one. That goes for all the teams. I think, to some extent, we're really trying to construct the next generation of research. So of course we have a long history, but sometimes we have to also challenge our own histories. So, be mindful of it, be resourceful, but also look for novelty in terms of pushing new paradigms and this kind of stuff. And I think the conversations between the studios, you see that we're entering, I think, interesting conversations from before, from blockchain to now, like talking about, operating clouds. This is when DRL is at its best, when we can have those conversations happening through the work that we're doing. So please really also look at the different ways the studios are working, and try to be mindful of that. Okay, can we get the next team?
Thank you.
Hello.
Thank you.
All right,
Can I
guys.
share my screen?
Yes, yes, please do. Can you